In today's lesson, we're going to look at a geometric sequence and try and figure out the pattern for one, and use that pattern to help us identify what the formula for a geometric sequence should be. And we're going to build off of the Desmos activity we did in class. Let's get started. To begin with, let's see what it means to be geometric. A sequence is geometric if the ratios of consecutive terms are the same. As an example, we're going to use Daryl's kill count per season of The Walking Dead. Of course, these are not real numbers, I've just made them up. So to begin with, he had 2, 8, 32, 128, and then 512 kills in each season. We're going to evaluate the difference between, or the ratio between, each one of these seasons. To do that, we're going to divide consecutive terms. If we divide consecutive terms, then we have 8 divided by 2, which is 4. 32 divided by 8 is also 4. 128 divided by 32 is 4. And 512 divided by 128 is 4. So what this means is, each season he was multiplying the previous number by 4 to come up with the next term. So we have a common ratio, which is 4. Since we have a common ratio, we then can say that we have a geometric sequence. So just to recap, if you are multiplying by the same number each time, then that's your common ratio. If you have a common ratio, we can then say that our sequence is a geometric sequence. See if you can identify if the following three sequences are geometric by finding a common ratio. So, you can answer these questions by saying yes or no, that they are geometric or not. If they are geometric, please write down the common ratio. Answer these questions now. Now that we know what a geometric sequence is, we can come up with the formula for a geometric sequence. And you may have identified this from the activity using Desmos, but our formula is going to be a sub n is equal to a sub 1 times r to the n minus 1 power. R is going to be your common ratio, and a sub 1 is going to be the first term. For our first example of finding the formula for a geometric sequence, we're going to examine the number of walkers that occurred in each episode of The Walking Dead Season 1. So to begin with, we had 15 walkers in the first episode, 75 in the second, 375 in the third, and 1,875 in the fourth episode of Season 1. The first thing we want to identify for our formula is what is our first term. So in this case, our first term is a sub 1. Now that we know what our first term is, we want to find our common ratio, which we're going to find by dividing any two consecutive terms. So if we divide 75 by 15, we get that our common ratio is 5. We then want to verify that this ratio works for our entire sequence. So as we look ahead, we can see that the third term is 15 times 5 squared, again a power of 5. The fourth term is 15 times 5 to the third, which means we now can plug in our a value and our r value into our equation to get our geometric formula, which is 15 times 5 to the n minus 1 power. For our next example, we're going to examine the number of times someone almost died during each season of The Walking Dead. In the first season, someone almost died 7 times. In the second season, someone almost died 21 times. And in the third season, someone almost died 63 times. Now this pattern continues, so we're going to come up with a formula that models it. To begin with, we want to find our two values, the first term and the common ratio. The first term is of course 7. To find our common ratio, we're going to divide any two consecutive terms. In this case, we divided 21 by 7 and got that our common ratio was 3. Which means as we plug them into our formula, we have 7 times 3 to the n minus 1 power. This will now tell us the number of times somebody almost died in any season. So let's make a prediction. Let's say we wanted to know how many times someone's almost going to die in Season 9. That means I'm going to plug in a 9 into our n. If we do that, then we come up with 7 times 3 to the 8th, which is 45,927, which means that our ninth term is 45,927, or that someone will almost die that many times during Season 9. Now we are not always lucky enough to have consecutive terms. Here we see we have two terms that are a little spread out. We have the 7th term and the 15th term. So what we're going to do is develop a formula to help us find the common ratio when terms are not right next to each other. In order to do that, I'm going to label my first term as a sub m and my second term as a sub n. For my formula then, the common ratio is going to be the n minus m root of a sub n divided by a sub m, which means that my m is going to be 7, and n is going to be 15. As I plug things in, my ratio is then going to be the 15 minus 7 root of 384 divided by 24. This is going to simplify to be the 8th root of 16. Now you might not know how to take the 8th root of 16 in your calculator, so a different way to think about this is it's going to be 16 raised to the 1/8 power. And that equals approximately 1.41. And now that we have our R value, we can go back and find our sequence. We're going to go ahead and plug things into our generic geometric formula, which again is a sub n is equal to a1 times r to the n minus 1 power. What we don't know right now is what is a1. So in order to find that, I'm going to plug in a term. Let's say I plug in my a sub 7 term. That means I have 24 is equal to a sub 1 times 1.41 to the 7 minus 1 power. So that's going to give me 24 is equal to a sub 1 times 1.41 to the 6th. And now I can divide by that to solve for a. When we divide both sides by 1.41 to the 6th, we get that a1 is equal to approximately 3.05. So now I have my first term and I have my common ratio. I can plug those into my formula here, and I get a sub n is equal to 3.05 times 1.41 to the n minus 1 power. To check that formula, I would plug in a 15 for n and make sure that I get 384. So if I do that, if I have 3.05 times 1.41 to the 15 minus 1, I should get approximately 384. And when I plug this in, I actually get approximately 374.42. Now the reason why that number is so far off from what it's supposed to be is because our R value and our a sub 1 value have been rounded. So I just want to emphasize that how important it is to make sure you're as accurate as possible when you're doing these problems to make sure you avoid that kind of a problem. Alright, I want you guys to go ahead and try and find the common ratio here, and then use that and one of these terms to try and find the formula for the geometric sequence. So go ahead and answer that question now. For our last example, we have a herd of 32 zombies that is left unchecked on an island off the coast of Alaska. It's estimated that the herd is going to increase by 18% each year. Our first question is to estimate the size of the herd after 5 years and after 10 years. And then we're going to answer how long it will take for the herd to reach 5,000. To answer the first question, we need to know our first term, which in this case is our initial population, 32. We also want to know our common ratio. Now, it's really important we understand the idea of our common ratio when we're dealing with percentages. So I'm increasing by 18% every year. That's in addition to what we already have, which is the 100% our population represents. So if we're increasing, then we're going to be adding 18% to 100%, and we get 1.18 as our common ratio. If instead our population was decreasing, then we'd be subtracting the rate from 100%. So we would have had 0.82 if our zombie population was decreasing. But again, since we're increasing, we're going to add that value to 100 to get 1.18. This means that our formula, a sub n, is going to be 32 times 1.18 to the n minus 1 power. To find the number of zombies we have after 5 years, we would plug in a 5 for n. And to find the number of zombies after 10 years, we'd plug in a 10. Now, since we're dealing with zombies, that represents a whole individual, so it's appropriate to round our answers here. For 5 years, we would have approximately 62 zombies. And after 10 years, we would have approximately 142 zombies. Alright, now for our next question. How long will it take for the herd to reach 5,000? The way we're going to answer this question is by graphing. So we're going to graph our exponential growth function, which will look something like this, and we graph the equation of 5,000 is equal to y, and then we're going to try and find the point where the two intersect. And that ends up being the point 31.52, 5,000. And what that means is that it's going to take approximately 31 and a half years for our herd to reach 5,000 zombies. Alright, that concludes it for our notes. Go ahead and do the homework. Remember, the homework is due when you walk into class on Monday. Alright, have a good weekend.